For thousands of years, the relationship between land and sea felt permanent. Our coastlines were constants. But in the last century, something fundamental changed. The ocean began to rise. And now, new data reveals something even more alarming: it's not just rising. It's accelerating. And what's coming next could redraw the map of our world. To understand how serious this is, you need to know how we measure it. Since 1993, we've had satellites in space acting like ultra-precise ocean rulers, bouncing radar off the sea surface to track changes down to the millimeter. This isn't guesswork, it's high-tech, global fact. And the fact is this: the rate of global sea level rise has more than doubled in just the past 30 years. We're now adding over 4.5 millimeters to the ocean's height every single year. In 2024 alone, it rose a shocking 0.59 centimeters, way above what scientists predicted. Think of it like pressing the accelerator on a car that's already speeding. So, why is this happening? Two main reasons. First, the oceans are getting hotter. They absorb over 90% of the excess heat trapped by our greenhouse gases. As water warms, it expands. This is called thermal expansion. But the second reason is even more visual: ice is melting. A lot of it. Right now, the Greenland ice sheet is losing a mind-boggling 9 billion liters of ice every single hour. That's like emptying 3.6 Olympic swimming pools per second. And in Antarctica, the Doomsday Glacier, Thwaites, is disintegrating faster than models expected. If it goes, it could unlock over 3 meters of potential sea level rise on its own. We are literally watching the pillars of our planet's ice architecture crumble. This global average translates into local nightmares. Sea level rise isn't a uniform bathtub fill. It hits some places much harder due to ocean currents and sinking land. And the places first in line aren't the giant industrial cities you might think. They are small island nations. Places like Tuvalu, Kiribati, and Fiji. NASA analysis shows that even if we magically control emissions tomorrow, these islands are locked in for at least another 15 centimeters of sea level rise in the next 30 years. For nations whose highest point is often just 2 meters above the waves, this isn't an inconvenience. It's an existential threat. Saltwater is poisoning their soil and drinking water. High tides now regularly flood homes and roads. Faced with this reality, the world is scrambling to adapt. From building sea walls in Europe to designing floating homes in the Maldives. But for some communities, adaptation has a much more final meaning. They are being forced to abandon their homes. In Fiji, the government has officially identified 42 villages for relocation. 6 have already been moved, whole communities uprooted from the land of their ancestors. This is managed retreat, and it's one of the most painful human consequences of climate change. Meanwhile, nations are fighting for legal recognition, with Tuvalu signing a groundbreaking treaty with Australia to protect its statehood even if its physical territory is submerged. The big, terrifying question is, what comes after 2050? The truth is, there is a huge range of possibility, and it hinges almost entirely on two things: our emissions and the stability of Antarctica. Scientists say we have likely already locked in about 1 to 2 meters of long-term sea level rise. But if the warming triggers a runaway collapse of major ice sheets, a scenario we can't rule out, that number could be vastly higher by 2100. The difference between a challenging future and an unmanageable catastrophe lies in the decisions we make this decade. Cutting emissions aggressively is no longer just about stopping warming, it's about slowing down the rate of rise to give billions of people in coastal cities a fighting chance to adapt. The story of sea level rise is a story of sobering physics and profound human consequence. It's a global trend with intensely local impacts, from the glacier of Greenland to the shores of the Pacific. The data is clear. The acceleration is undeniable. And while the uncertainty of the coming century is daunting, one thing is certain: the faster we move beyond fossil fuels, the more options we leave for every coastal community and future generation. This isn't just about saving the planet. It's about saving our homes. What do you think are the most viable solutions? Massive engineering, global cooperation, or something else? Let's discuss in the comments. If you want to understand the other major threats from our changing climate, hit subscribe. We'll see you in the next video.